Hi everyone, I'm Dmitry. I've been programming Java for about 10 years, and for the last 3 or so years I've been programming only Kotlin. So this talk is done from the point of view of basically Java developer. So if you know Java, Scala, Groovy, you should be fine. I also tried it with people who don't know those languages. You should still be fine. And as you can guess from the title, it will be about live coding in Kotlin native Snake. And before doing typing code, I thought it would be nice to have a small 5-minute lightning talk about Kotlin native. So what is Kotlin native? So similar to Kotlin, it's an open source project which is supported by JetBrains. And this is the home page, the closest you can get. There is a problem with it. It doesn't say that it's beta, so I corrected it. Kotlin native is in beta, and as it says on the page, Kotlin native is technology for compiling Kotlin code to native binaries which run without the Java virtual machine. So it's like standalone binaries using LLVM compiled to native code. So this is the GitHub page for Kotlin. It's native, it's Apache 2 license, it's developed by JetBrains people, and you can check out the source code anytime. So here is a bit more technical definition from this GitHub repo, which says Kotlin native is the LLVM backend for the Kotlin compiler, blah, blah, blah. If you're not a compiler developer, it can be a bit confusing, so I'll try to explain the definition. So one thing which might not be obvious, what does it mean to backend for the Kotlin compiler? What does it mean? And so from compiler point of view, the way they work, for example, you have a source code file in Kotlin, and compiler transforms this source code file into another file, can be in-memory file. It's from Kotlin language into intermediate representation. And from intermediate representation file, it transforms it into Java bytecode in this case. So the first step is done by compiler frontend, and the second step by compiler backend. So there are a few backends for Kotlin. So there is JVM backend. There is also JavaScript backend, so you can compile your source code from Kotlin into JavaScript files. And there is Kotlin native backend. So there are 3 backends and 1 frontend for Kotlin compiler. So this is Kotlin native backend, and the whole thing is called Kotlin native. So that's one thing. The other thing is LLVM. So this is LLVM logo. There are a couple of funny things about LLVM. It looks like it should be virtual machine, and it's not. It looks like an acronym, and it's not an acronym. It's been de-acronymized. And this is the home web page for LLVM. By the amount of CSS, you can guess this is not a JavaScript framework. So in reality, it's a set of tools for creating compilers, and it's very fundamental for many technologies. If you use any of these languages, that they are using LLVM. So if you have Apple device, basically the chances are binaries were created using LLVM. So for Kotlin native, it's a good company to be in the same group as Rust, Swift, GraalVM, and so on. And the way it works, this step I showed, it was a bit of a lie. What actually happens is that Kotlin intermediate representation transformed into LLVM intermediate representation language. And the last step is done by LLVM. So this way, Kotlin native can leverage infrastructure and not create native binaries itself. So the last step is just leveraging LLVM. And the last thing is runtime implementation. So in Kotlin, at compile time, for example, you use a class called kotlin.string. At runtime, it becomes Java length string. And on JavaScript, if you compile to JavaScript, it becomes JavaScript string. And for Kotlin native, it becomes K-string. So it's C++ code. And there are a bunch of those classes in Kotlin package which compile to the appropriate platform-specific code. So that's the whole standard library for Kotlin. And there is also, in native, there is reference counting and native-specific code. So hopefully this definition is a bit more meaningful. So it's a LLVM backend, which uses LLVM, of course. And there is platform implementation to compile Kotlin into native, a set of libraries. Then why would you use Kotlin native? And one of the important things is performance, and not necessarily in the sense that it's faster and so on. It can be just more predictable than JVM because it's a native standalone binary and so on. So if you want, I would recommend this talk by Martin Thompson about different aspects of performances. Then the other thing is that there are lots of C APIs, and I feel in Java community we don't use them that much, even though there are actually lots of APIs, and in many other languages it's a common practice just to use them. And third thing, at least for me, it was definitely Kotlin, because if you know Java, Scala, Groovy, you pretty much almost know Kotlin. And if you know Kotlin, you can write native code now. So that's another exciting thing, that it's like easy transition for Java developers without learning C++ or Rust. So that's the end of the lightning talk. Now, moving on to actual live coding, I'm going to do a snake video game where you control, in 2D space, you control a snake, which eats apples, and so on. Then for UI, I'll use very simple UI, which is a native library called ncursors, which basically transforms terminal into canvas. And you can draw it. As a disclaimer, I'm not going to write many unit tests just to save time. And this will be a happy path. So, like, normal development doesn't happen like that. So here is some source code, and it's hello world. And what I can do, I can open command line at the bottom, and I can do conc src main. So conc is a name of the compiler for Kotlin native. It's the same equivalent of Java C. And if you're familiar with C++, there is Conan package manager. It's absolute coincidence, so these are not related things, right? And after I run compilation, it produces this file called program kexc. It's executable, Kotlin executable, and it's like 0.5 megabytes, right? If I run it, as you can guess, it prints process ID of the current process, and because it terminates every time it's a new PID. So the interesting thing here is that we can open a man page, like, if you go to console and type man get PID, this is the output you will get, and this is basically a description of C function. It comes from this header, uni_std, and that's like C signature. So basically it means takes no parameters, void, and returns something of type PID_t, whatever that is. So what we can do here in Kotlin, we can extract a variable, and just like forgot to mention, this is IntelliJ, so it really is like normally Java ID. So we can extract this variable, can say in Kotlin specify type, and as you can see, it's the same type as in C code, right? And we can even like click through and see that the actual definition becomes Kotlin int after all. So I can go back, and another interesting thing you can see, it comes from import platform.POSIX. The reason it works is because Kotlin native knows that it relies on POSIX to be available, and it just generates bindings, so you don't need to do anything special to use POSIX. We can also click through, let's say, get PID function, and then do select in project view. And if I collapse all of this, we can see if you use IntelliJ, this looks pretty much like a normal jar file, which dependency of your project. And so there are lots of OS X specific things over there. But overall, the reason it works is because it's configured via a Gradle file. That's how IDE knows about it. And in Gradle file, all you need to do is say this is multi-platform, this is Kotlin version, and normal repositories thing. And then this is Kotlin native specific thing. You say that's your target platform. These two lines just to simplify folder structure, so it's like not nested, like Maven style. And here I'm saying this is binaries, and binaries will have debug information in them. And this is the function you need to call to run native code. And that's pretty much it, how the project is set up. Obviously, because it's Gradle, we should be able to run it via Gradle. So if I open Gradle window, it should run. Run. So you can see it runs from Gradle as well. So that's maybe a more standard way to use Gradle. So this was advanced hello world. So I'll delete this code and move on to the actual game. So maybe the first thing we want to define a snake as an object and make sure that snake can move. So I'll define snake as a data class which will have cells. It will be like a list of cells where cell is a data class with x and y coordinate. So it will be x and y of type int. And snake will have a direction which will be in enum. And direction, because 2D space will be up, down, left, right. And let's make it like classic console games. So these are the directions on the screen. So the beginning is the top left corner. That's the beginning. So we can have snake object here. And if you're not familiar with Kotlin, there is no new keyword. So here we create an object, and we create a list of cells. This is just a name. It's like a named parameter to constructor. And let's, by convention, have the first cell as the head of the snake, and then we'll have just 3 cells, 2, 1, and 0. And direction will be right. then I can define a variable called snake, and we want something like snake move. And it will be like very functional design that snake.move creates a new snake object, basically. So what we can do, we can write an assertion here after snake moves, and we expected that direction will be still right, but the x coordinates will be +1. And then we can create this function as a member on snake. And just for now, let's return this and just run the snake object. So what's going on here, like another thing I just used, assert equals. This is similar to JUnit, but it comes from Kotlin package, so it's one of those standard library functions. So that's why we can do assert. And just like in Java, we can invoke a function anyway. It doesn't have to be in the test. So here, as you would expect, it fails because we didn't really implement this move function at all. If I do a rep, so we can see that it expected snake with cells 3.0, but actual was with 2.0 and so on. And also we can see there is a stack trace, but it's not the Java stack trace at all, so you can see this is a native file calling everything, and there is like, we can click on the stack trace and it takes us to the line in the code where it failed. Like if I click, it jumps to the right line. So let's implement this function. I won't do it in the simplest way because it will be useful later. So I'll do it a bit more complicated way than necessary right now. So it will be basically new head plus new tail, and we can create a new head, as in like the first cell is current head, and we'll move our head in some direction. Then we'll have a tail, and new tail will be all the cells except the last cell. So basically, we don't move all the cells, we just create a copy of the head and drop last cell. And for moving cell in the right direction, what we can do, basically create a new cell. It will be x plus direction dx, and y plus direction dy. And for direction enum, we can also define dx and dy. So for up, it doesn't move horizontally, so it's -1. For down, it's the opposite, 0, 1. For left, it will be -1, 0. And for right, it will be 1, 0. So now if I run it, the test should pass. So just to go through it again, what we do on snake move, we create a copy of the object with new cells, and new cells mean we move head in the current direction and drop the last cell from the tail. So now everything passed. It's hard to see what happened, but so this was obviously not the right thing to do. We should move it into tests. So I'll just cut this code and move it into tests. So let's have a class called snake tests. And there will be a test called snake moves, right? And basically I'm pasting the same code. And I can also, to run tests, unlike Java, there is currently no support. I cannot click here, but I kind of can run it through Gradle, so like snake test, run it. And basically it's like the same code, but as you can notice, in normal Kotlin, you can use function names with backticks and use spaces in them, which is quite useful for test readability. And there is also this annotation. It also comes from Kotlin test. It looks a bit like JUnit, but it's not. And the rest is just assertion. So again, this was the execution of the test. Unfortunately, Gradle doesn't print exactly which test it ran, but there is a way to do it from console. So I can go to the folder called bin snake debug test. And in this folder, there will be a file called test. And if I run this, it actually executes the code we just wrote, right? And I think that's how Gradle works. It basically creates this executable file, runs it natively, then parses std out and presents it to you via Gradle, whatever standard methods. And then it's picked up by ID through that. So that's like the snake moving. So this was maybe just a bit abstract businessy logic. So maybe it would be good to switch and do a bit of UI things. And so for UI, as mentioned, I'll use ncurses, and I'll just use some functions from ncurses library and explain in a second what they do. Like the first function we need for ncurses is called Init Screen. If we open men file for it, you can see it comes from curses.h, and so it's not part of POSIX. And basically, you can read description like, online, find some. Basically, it's the first function which we need to call, which switches terminal mode into like different mode, right? And at the end, we need to remember to call endWin to go back to normal terminal mode. Otherwise, it's not going to work that well. Then we want to have width of the game field and height. This will be like 2010 because terminal is not proportional, right? And then we want to maybe create a new window of height, width, and this. So if I look at man file for it, it's like number of lines, which is height, columns, and shift by y and x is going to be 0. And this returns a window, right? So let's define variable called window. Then this window is like a native window from n cursor, so we need to remember to delete it. Then the whole point of window here really is to be able to draw a box around it. So this should be window. And here there are some unsigned literals in Kotlin, which is a new feature. So that's why I'm suppressing them, because it's going to complain. Then after the window, maybe we want to move to some position on the screen. Let's say inside the window, we go to whatever, row 3, 2. And then we print like as a simple prototype textual representation of the snake. So it's its head, and that's like a ton. So then for n cursors, just to tell n cursors, definitely draw it on terminal with this window refresh. And then because we need to like read a couple characters because this is a blocking function, so we can have a chance to actually read what's going on the screen. Otherwise, it will like initialize, draw, and go back to terminal and erase everything it displayed. So just to reiterate, we initialize in Init Screen, we create in window, then we doing things with window, all these variables, all these functions use window now, and we draw some stuff on screen. So now I can go from this folder one level up to debug executable, and there will be snake cax file. So if I run this now, you can see that's the window, and that's the snake. If I type 1, it kind of prints it back, which is not so cool for the game, so there is no echo command for n cursor, so it will stop showing whatever I type. And there is also blinking cursor. For this, there is function cursor set, so basically there will be no cursor. Now if I press 2, it just goes back to normal terminal mode. This looks okay. And this like the basic n cursors use case. So it might be a bit more tricky than it seems at the first sight. So if I open man page, for example, for this function, which prints something to the screen, and we can look at C signature. So the first parameter we get is basically win. It's a pointer to a structure window. Here, with type inference at Kotlin, you don't even see the type, but we can say specify it explicitly. And this question mark means it's nullable, so I'll just do this, pretending it can never be null, but just for simplicity. But then you can see Kotlin native represents pointers as like a class, which takes as a type argument window, and window is basically type ls for this thing, which is ultimately a C struct. And I'm not going to go into details, but that's like a bridge code. So that's the first argument. The other two arguments, in C code, they're just lowercase ints, which is like normal native int. In Kotlin, this is definitely not just an int because we can call things on it, like range to and so on. But it's still kind of believable that Kotlin int and native ints like easy to convert. This thing is a bit more tricky because this is a string and you can do something like Java-like things like to lowercase. And in C code, you can see this is a pointer to constant character, this signature. And this is like less obvious. And the way it works in Kotlin native is like similar to Java. It represents string in two ways. So part of the Kotlin native string is written in Kotlin. For example, that's the source code. It's like I just checked it out on my laptop. So for example, this function is implemented in Kotlin, but hash code, it says it's external, which is equivalent to keyword native in Java. And then it says that's the function name in like C code. So if I switch to C code, that's like C++ part of K-string. And if I search here for this function name, so that's how it's actually implemented in C++. So at this point in our source code, basically this string is really C++ code. And the reason it works is because Kotlin native generates binding bridge code. So if I like click this function and go into here, you can see that in Kotlin signature, it's still kind of Kotlin string, which is K-string, but then it annotates it so that it later on converts it into C string. So it does some bridge code. So in a way, basically, Kotlin native, just like JVM code, tries to integrate very nicely with C libraries. So for JVM, they try to integrate Kotlin with Java really nicely, and for C, it's C, so just making everything easier. For example, like in Scala native, you would have to do something like C screen or something like that. So it's not so nice. So that's maybe like what's the basic thing. Maybe we should make it interactive and basically create a game loop. So let's say we have variable input, and while input, which is integer converted to character not equals to q, which is for quit the game, we can do, we need to clear the screen now because we're going to paint many times. And then we're going to assign output into the input. So that's the main loop. Then we need snake again. I'll take it from the test for now. And then we want to update snake in this loop, right? So we want snake, move, and I'll change it to var. And we also want to, like, I'm not going to draw the whole snake straight away, so let's say cells.first.y, because this is, no, it should be x here. So in any case, that's the idea. So what's going on here is that we have input, we draw current snake on the screen, this is a blocking call, then we move snake to one character right, and then we draw again, and because it moves right, it will move it by one character, right? So now if I type something, it kind of moves on the screen. It goes a bit funny at the end, but and if I press Q now, it exits. So one problem is that I had to type to make it move. To get around this, there is a function called half delay. It basically means that wget will, after 200 milliseconds, it will just return 0 if I don't type any keys. Right, and then we probably want to draw this, draw snake properly. So let's do, instead of this, let's do head, and it's going to be member property head. And that's cells.first. This is also cells.first. And then we also want snake head.y here, right? So it properly paints the head, and that's the head. Now in Kotlin, we can use different, let function. So inside let function, head becomes it. It's like default. This is basically a function which takes a lambda. So that's the actual signature. But if the lambda is the last argument to the function, we can move lambda out of parents, and the only argument which comes in can be called it. So similarly, we might do something like a tail of the snake. So we can create tail, and it will be cells drop first. So it's like all cells except the head. And for tail, it's going to be multiple cells, so we can do for each and do something like that. So now we basically, for each cell in tail, we print it at the appropriate coordinate, and the same for the head. So now if I run this, it moves without me typing. There's half delay, and as you can see, snake is much smaller because we only had 3 cells. It's a bit, like one problem is that it's small, so it should be easy to fix, right? Just add maybe a couple more cells, so it's more fun. And then the problem is that it also goes at the top row, which is not the play field. And the problem with this is that it happens because the width and height of the window, not the actual game. So probably we should do +2 because it's like a frame. It's like one side on the left and right. And also when we print snake itself, we should do +1 here. So that should fix that problem. But in general, like maybe as the next step, it would be nice to make snake like more interactive. So I'll write the last test here, which will be for moving snake around. So let's make this private, and I'll collapse this function for now. And let's say it will be snake changes direction. So let's say we have snake, which moves right, and we say turn down. And when it turns down, it should stop moving right, and its direction should become down. Right, so that's what we expect. That's a normal case, and there is another edge case when snake moves right, but we tell it to go left. And it becomes a bit more tricky, but there are different ways to do it. You could like flip snake around, but I'll go for maybe a slightly simpler or realistic approach. Basically, if it's the opposite direction, it will just ignore the command and just keep moving right. So that's the test. So I'll create function on the snake, which takes new direction. And if new direction is opposite, then we want to ignore the command. It's like opposite to current snake direction. So that's what we're doing, right? So then it returns the current snake, which is this. Otherwise, it's a copy of the snake, basically with new direction. So when we turn, it doesn't really move. It just remembers how to move, where to move. And is opposite is not that hard to do for direction. So it basically will be if dx of the current direction plus dx of that direction equals to 0, or dy, then it's the dy. Then it's the opposite direction. So up and down are opposite, like -1 plus 1 is 0. That's the idea, left and right. So if we run the test, it should work. So overall, what we want, like hopefully it passes, then what we want to do is basically plug it into here and say snake turn in some direction. Right. And then direction should come from our input because I want to control it from the keyboard. So something like that. That's what we want. So if we look at the output, the test passed. It's good. And so now we can try read the input, converting it to character. For navigation, I'll use IJK layout, which is like I is up, is left, down, and right. This is like transposed arrows. And you could use arrows, but it's just a bit more effort for N cursors, just a bit more complicated code. So I'll just go for this. So J is left, K is down, and L is right. Because when is an expression, it needs like to be exhaustive. So there must be an else case. And for else, we could use current direction of the snake. So if you didn't type one of these keys, nothing will happen. So now we can run this again. And here now the idea is that snake movement will actually work because when we implemented this move function, we did it in a bit more complex way. So now, again, we're just making a copy of the head and drop the last cell. So no matter what the shape is of the snake, it should follow it. So now if I press it, it kind of moves around in a funny way. So this is already kind of somewhat playable and somewhat fun. It goes off the screen, though. That's like not what we want, I guess, eventually. And if you go off the screen, you can lose it forever. So far this was kind of fine. And now to switch off it for a bit from the game, there is always like a big hidden elephant in the room when you talk about native and don't mention any memory management. Because that's like the biggest difference with virtual machines is that there is there is no garbage collector normally. So, at least like you should mention this. So the way it works in Kotlin native is that if there are objects, for example, like snake, and we constantly create a copy of the snake, right? So on every turn, we create a copy. On move, we create a copy. If it's Kotlin native object, Kotlin native uses reference counting. So basically, in this case, we had snake here. Then we do snake turn. It returns a new instance of the object. Then we do move. It returns a new instance. So previous two instances, they're not referenced by anything, so memory can be reclaimed automatically. So there is some strategy inside Kotlin native. As I understand, it is actually pluggable, so you could define simple GC, or like there are plans to make it definitely pluggable. Right now, if you can modify source code, I think. And so, but yeah, currently it's just reference counting. For cells, for snake, it's reference counting. But there are also native objects like this, and cursor's window, because that's a pointer. Window is allocated somewhere on heap. Heap means like Kotlin native doesn't control this bit of memory. So for those objects, you have several strategies. And basically, I'll just write some code to explain it. So there is a global object called native heap. And there you can go just basically C-style. And you can say, allocate me this data, this struct time spec, also from POSIX. Right, so you can just say allocate. Then you assign it to a variable, let's say time spec 1. Then you do time spec 2, and then you need to remember at some point to deallocate memory. If you don't do it, it's a memory leak, right? Time spec. What I want is this, time spec 1. Right, so then you can do it twice. If you do it twice, it's going to crash. If you forgot to, that's memory leak. You can also do the same thing with window, but in our case, it's not the right thing to do because window does some other cleanup. This function delwin, I think, is doing some other cleanup. So that's like classic C style. You basically do memory management manually. The next option is to use zoned memory allocation in Kotlin native. It's called Arena. So you can do a similar thing like allocate time spec again, let's say. You allocate a couple of variables. It's going to be T1, T2. then you don't really need to keep references to those variables. You can just do arena clear, and it will deallocate all the memory for these two variables. And the third option is to use a function called Mem Scope, which takes a lambda. That's a lambda syntax again. And there you can do timespec allocate. You can allocate things, but as soon as you reach the end of the lambda, all these variables automatically cleaned up. There is a small twist on it, is that Arena has this function called defer, and that's a callback. It's just the code which will run before cleaning up these two objects. And the same thing for Mem Scope. So in a way, it's not a destructor, but it's something like a similar callback. And you can do the same thing in defer. So for our purposes, we cannot really, we could use free for window, but defer would be a better option. So I'll delete this code and basically use Mem Scope then. So here at the top, I'll just plug this as a Mem Scope. So our whole function is Mem Scope now. And here, after initializing screen, I can call defer and say, once we initialized, we immediately set a callback to clean up the whole screen. So if something happens, this will be called. If exception is thrown, Mem Scope will catch it and call this defer. And same thing can happen with window. So we do window, delete window. And that's a good way to do it, because we should not forget, as soon as we did some memory allocation on the next line, we remember how to deallocate it. And that should work the same way as before, pretty much. So functionally, there will be no difference. So now moving on back to the game functionality, what we might want to do is some cleanup. So I'll extract object called game. So game will have width type int, will be height of type int, and it will have snake. So basically, I'm trying to encapsulate those three things like these lines, right? And so we'll have game, it will have width, height, and snake. And now we want to use game instead of these three variables. So let's say here I want to do game.height, game.width, and so on. So I'm just replacing everything. And here we want to update game really. So it will be some game.update direction. And game should be variable. And inside update, I'll just copy paste this code for updating snake. So game update returns a copy of the game with new snake. So this is equivalent to what we had. Now these variables, they're only used once. So we can inline snake, inline height, inline width. Can put them on new lines and maybe add names, so it kind of looks nice. So now everything, those two are used via game. Also maybe this bit could be cleaned up and let's say extract draw function. So now we're drawing game on this window. And here we can use extension function from Kotlin. So it was window and now it's called this. We're basically pretending that window is the class of this thing. So now it looks nice, a window, draw, game. So yeah, that's the refactoring. And the next step, maybe the game should end somehow. So let's have game is over thing. And there we can say, if game is over, we want to print, let's say in the first line, we say game over. And on the second line, we'll say, we'll show the score. Your score is, and we say game score. So game score will be super easy. It will be just the length of the snake, because the more apples you eat, the more difficult it is to survive, right? And then there is game is over, which is also not a very difficult thing to do. So there are two conditions. One is when snake bites itself, it means its head in its tail. And the other condition is that the snake goes off the screen. So it means there are cells, if there is any cell, and its coordinate, x, outside of the range between 0 and width. This is exclusive with exclusive range. And the same for y, so it's not in the range between 0 and height. And one more thing, if game is over, we should stop updating it. So if game is over, we don't move snake, basically, that's the idea. So now what we did, a bunch of refactoring, so now everything inside the game, and we added these 3 lines for game is over. And game is over when snake bites itself, hits any walls, and we get the score as the size of the snake. So that's the idea. And the game stops progressing once it's over. So now if I go left, the game is over. If I go down, it is over. It's a good example for unit testing. So now like testing up. And the last one to like quickly turn and bite yourself. Yeah, so this seems okay. So like manual testing. So the next thing, like to actually make it more playable, we need something like apples, because just snake on its own is not enough. So apples, it will be more like a field of apples. It also have width and height, and it will have some cells in it. It will be a set of cells though. And by default, you can have default values for constructors, so that's a class and that's a constructor in Kotlin, and you can have default values there easily. And so I'll also define random, which is not useful in this example, but if we were writing tests, we would want to control randomness, right? And then I'll define growth speed, which I'll explain in a second, as will be 3, just some number. So that's unused, that's a safe transformation, right? And then we can have apples inside game, apples. And by default, it will have the same width and height, and the rest of the arguments, they're defaults. So now what we want on game update, we want to create new apples so that they grow. So say it will be grow function. And grow function will do, the first place will be random next int out of 10. And if it's less than or equals to growth speed, then nothing happens. That's basically like roughly 70%, nothing happens. That's the idea. Otherwise, we create a copy of apples with all the cells plus a random cell. And random cell, as you can guess, will be next int from 0 to width -1 until width, and random next int until height. So that's generating cells, and like the one more thing, we need to be able to draw those things, right? So we need to game apples, cells, and actually draw them on the screen. It would be nice to use here something like an emoji. Unfortunately, emoji more than 1 byte long, and it's a bit more complicated with hand cursors. But it would be cool to have an emoji. You can actually do it, but then you need to configure terminal and just use different hand cursors library compile it differently. So now you see we get apples at random places. But snake still like just goes through them. That's almost what we want, but like we need the last bit, which is snake eating apples. And to do that, let's look at this function where we update snake. So let's call it new snake. And what's going on here is that snake changes direction, like turns, then moves, and then we want something like snake eat apples. But then we want apples to grow as well. But if we eat an apple, it should disappear from the whole apple field, and because it's very functional design, we need to kind of remove apple, and all objects are immutable. So the solution here is to have it to return 2 things, new snake and new apples. So then we can do something like that. And then if we define int function, it takes apples and it returns a pair of snake and apples. Again, the first condition should be simple in the sense that snake eats apples with its head. So if snake's head not in the range of apple cells, then we do nothing, right? So then we return a pair of the current snake and apples unmodified. Otherwise, we return a pair with some modification. So for snake, we'll have the counter, create a copy of snake with the counter eaten apples. And it will be +1. I'll create it in a second. And apples will create a copy with all the cells from apples minus snake's head. So because apples and apple cells and head is the same type, we can do minus, which is just subtracting, removing an element from an array. And so now let's create eaten apples variable, it will be part of the snake of type int, and by default it will be 0. So now, so far what we have is basically we remove the apple and from the set of apples, and we increase this variable, but we don't use it. So now to grow the snake, we can do this trick when eaten apples, when we kind of move snake, and eaten apples is 0, we drop the last cell from the cell. Otherwise, we won't drop the tail. So that's how it's going to grow. And obviously on moving snake, we want also to kind of decrease this thing, but we don't want to decrease it below 0. So that's we can do max off. So that's the whole trick here. So there's this eat function, basically, if snake eats apple with its head, we update counter +1 and remove apple, right? And then on the next move, snake will grow by not dropping one of the cells from its end. To be fair, here it didn't have to be an int. It could be probably Boolean with this kind of game. But then you could maybe make it grow more than 1 if it's a special apple. That's an excuse for not optimal design. So now it seems like it's growing. And I'll try not to die for now. Let's see how far I can go. OK. Yeah, fine. So it's like right now, this is just approximation because it includes all the debug symbols, but that's 1.6 megabytes. It runs in a single thread, standalone file, right? If you run Valgrind, which is like profiling tool for C++, this is a bit old, but it's similar. I was also playing Snake games, so that's how much memory it allocates. So horizontally, it shows megabytes, but it's actually time, and vertically, it's the whole memory used by the process. So that's basically 1 megabyte. So that's not bad. You can never get it easily with Java, or even with Graal, it's not that good. And just to this was obviously like a toy prototype of the game, but even this exactly the same code, but with different UI, like better UI, using SDL library, which is a native library. So you can get something like this. So that's exactly the same gameplay. I did it too quickly, but you get the idea. It's way better graphics, game curving, and so on. Curving snake and so on. So this was a very short demo, really, of Kotlin native. So there are more things. So there is two-way interop with C and Objective-C. Two-way means you can use, as you've seen, native library like mcurses, but you can also use Kotlin native code from C, and similar thing exists for Objective-C. So there is also concurrency, other things I'm not going to mention right now. And obviously, you get all the beautiful native things like memory leaks and segmentation faults. So as a takeaway, if there was this continuum between C programming language and Kotlin for JVM on your right side, then I would say Kotlin native is closer to JVM Kotlin because it's just really easy to write and nice experience compared to just writing raw C, at least for me. And then there is also Rust and Scala native, and I tried them. I would put them somewhere on the left, so it's less smooth experience, at least for me. But obviously, this is not to scale. And if you can try it yourself. I re-implemented the same thing in Rust, Scala native, Go, and Graal VM. So you can check this on GitHub. I'll also tweet everything, and it's all online. People taking photos. So the other thing is that it's still early days for Kotlin native. I'm not affiliated with JetBrains, right? I can say what I think. And one thing is you may have noticed a slow compilation. As I understand, it's not really Kotlin native problem, it's more related to LLVM as well and so on. Then ID support is still not ideal. It's getting better for sure, but it's still, and also tools are not perfect yet. But it's definitely getting better, so hopefully sometime soon. What you can do next is obviously Kotlin is open source. On the GitHub, there is a samples project. There are lots of examples there. There are also good READMEs, very well written. The same README is available online in a nicer format, pretty much on kotlin.org. If you look for it, there are tutorials and so on. And there is way more stuff than I mentioned. Then there is important thing, there is Slack. It's still, because it's early days, there are not that many people, and the actual JetBrains team will answer your question, potentially. So other people, very helpful people in Slack. And I hope Kotlin native kind of evolves and becomes an important player in native space. So good luck to them. And this was Live Coding Kotlin Native Snake. Thank you for watching.